Welcome everyone to today's session. This is NPTEL course Environmental Chemistry live session, and today is the 10th week live session. I'm Saptarshi Bose here, a PMRF research scholar from IIT Madras. So we'll try to solve different problems, conceptual as well as numericals, using the Mintrix software. So today's topic is mostly regarding redox reactions. So the first question is directly from the concept of redox reaction, that the oxidation reduction you should have to match from the column in the right hand side to the column in the left hand side. So what is oxidation, what is reductant, what is oxidant, and what is reduction. We have to clearly mention it, clearly write it down. So I hope you are all are trying to solve this. Please write your answer in the chat section. So this is the answer, answer B. We will see. So B is the correct answer. That means A is related to Q. Actually, oxidation is the donation of electrons, right? And on the other hand, reduction is the acceptance of electrons, right? And then comes of reductant. So what will be the reductant? Reactant will be which will reduce other component, not about itself. And what about this oxidant? It will oxidize other component. Okay, so you have to think about this very clearly, that it is oxidizing other component, but it is getting itself reduced, right? So you should always think like that. So what the purpose, the job of the oxidant is to oxidize, but it is getting reduced itself. So that is the main fundamental concept here. So this is the what I said already. Oxidation is the donation of electrons by chemical species. Then reduction is the acceptance. Oxidant which oxidize other compound in turns become more reduced, right? So that's what I told you just before a few minutes. And then reductant reduces the other compound and it itself becomes oxidized. So that is the fundamental concept. So we'll go to the next question. This is related to the arsenic removal. Just a minute. Yes, this is related to arsenic removal. So in the arsenic present in the water sample, and there is some redox reaction process. So why it is preferred to convert arsenous, you have to write it down, arsenous form to arsenate form. That is 3 oxygen state to 5 oxidation state. Why? So this is the possible reaction, redox reaction, and you have to give the proper justification or reasoning from these options. You have to choose, right? This removal involves redox coupling, preferring higher oxidation state chemical compounds, or the removal is independent of the compound present, and both forms of arsenic are equally likely to be removed, or the third option, the arsenate form around pH 7 exists in both H2ASO4 minus and HASO4 2 minus, both enabling ion exchange for further removal. So we'll go for the answer. The answer will be C. So we will try to explain what is the reason that the presence of arsenic in the form of H2AsO4 minus and HAsO4 2 minus at a neutral pH, that is 7. So it will ensure the removal of high efficiency in ion exchange process. So when you are going for the ion exchange process, and suppose the water the water should be in the neutral pH, right? That's how we will be able to use that water. So we need water which for drinking purpose, for other purpose in our daily lives, and that should be in the range of the neutral pH. And if there is some arsenic present in the water, and I am preferring the ion exchange process, then this arsenate compound should be in the form of a charged state, right? So this is charged -1 charge, and this is -2 charge. So it will be easier for ion exchange system to remove these two ions, right? Because this is in the ion state. So it will attach to the column of the ion exchange system. So that is the basic reason behind this. So that's what it is written as: the presence of charges is required for ion exchange removal. If it is neutral, you cannot go for ion exchange process, right? Then the question number 3, again matching type of question. You have to match compounds with oxidation state. So from the basic understanding of the science and chemistry, which you are learning from your uh, standard, maybe 7 or 8 standard. So I think all of you know how to do this, how to calculate this oxidation state, and also you know elements can have which elements can have different oxidation states. So just you have to calculate what is the oxidation state of that elements. So already it is written here, so you don't need to even worry about it. So it is already written: carbon, chromium, antimony, carbon, etc. But from basic understanding, you also know which can have different oxygen states. So if for this carbonate ion, you have to find what is the oxygen state of carbon. For this, what is the oxygen state of chromium. So I hope everyone is trying to solve this. Please write your answer in the chat section. Okay, we'll go for the solution. Answer will be B. We'll check with every components. So first one is this carbonate, and you can write X. You don't know the value of C, the oxidation state of C. So it's very easy. You are doing this from your like seventh or eighth standard. So nothing to say more new here. So you will write X here, the in the place of unknown. Then oxygen has the oxidation state of -2. So I am writing 3 multiplied by -2, 3 number of oxygens are here. So 3 multiplied by -2, and this is total charges, total overall charges -2. So I am writing -2. So just calculate, you will find x equals to 4. So the charge of carbon here is +4, right? Then I will go for this chromium here. Again, oxygen has -2 charge and hydrogen +1. Overall charge is -1. Overall charge -1. Oxygen, so X unknown plus 4 multiplied by -2, that is coming from oxygen. Then +1 coming from hydrogen. This total equals to -1. Solve to 6. Same for SBF 6 -1. So I know what is the charge of fluorine. That is -1 charge. 6 into -1 equals to -1. So X equals to +5. And then for the last one, C2H3, O2 -1. Oxygen carries -2 charge, right? So 2 multiplied by -2, then hydrogen +1, 3 multiplied by 1, total equals to -1. So X equals to 0, right? So here carbon has no charge, or the oxygen state is 0. Let's go for this. Determine the correct statements out of the following. You have to write down which are the correct statements. For monoatomic components, the oxygen state is usually 0. In a covalent compound, the oxygen state of each atom is the charge remaining on the atom when a shared pair of electrons is assigned to the more electronegative of the two sharing them. Then the covalent compound with two similar atoms bonded together, suppose chlorine and hydrogen, has zero oxidation state. And then the last one, the sum of oxygen states for atoms in multi-atomic substances is 0 for molecules and equal to the ions formal charge. Okay, we'll go for the solution. Solution is T, and this is the first. D is the solution. So B, C, and D is right. So P, D, C, and P. A is wrong here. So for monoatomic components, the oxygen state is equal to the electronic charge. That is very clear for any monoatomic component. Suppose Cl minus. So the oxygen state is -1. It is equivalent to this electronic charge. Then in a covalent compound, the oxygen state of each atom is the charge remaining on the atom when a shared pair of electrons is assigned to the more electronegative of two sharing them, right? Then the covalent compound with two similar atoms bonded together. So these are the covalent bonded atoms, suppose, and it has zero oxygen state because these will share the electrons and both will have the same charge and it will be utilized. Then the sum of the oxygen states for the atoms in multi-atomic substances is 0. For the molecules, obviously for any molecules, multi-atomic molecules, there will be 0 charge, and like all the oxygen states, like it might be +2 and then -2 and whatever, +3, -3, and just like that. And then it will be totally 0 for molecules. And for ions, it will be the formal charge. Whatever formal charge is there present, that will be your sum of the oxidation states, right? Like CO2 minus, suppose. So this is an ion, this is an ion, and here if you just sum the oxygen states, you will get -2. So that's it. We'll go for the next one. Determine the reductant and oxidant in the following reaction. The reaction is given. You have to find out which one is the reductant and which one is the oxidant. You already solved a similar kind of conceptual question at the beginning of today's session. We'll go for the solution. So the correct answer is A, the oxidant which will the pieces which will accept the electron, right? And reductants which will give or donate the electrons. So here I can see that which one is accepting electrons. Cl, chlorine, is accepting electrons, and this one is donating electrons, right? So oxidant is chlorine and reductant is iodine, right? You can even see in the form of charge, like it was having some extra electron. This one is having some extra electron, is giving to the chlorine, right? So chlorine is accepting the electron, so now it has the electron. And what about this iodine? Now it doesn't have some extra electron. Let's go for this question. Find out the number of H plus ions in the balanced half reaction of the following couple: NO3 minus HNO2 plus. It's very easy. You should write down the half reaction and just tell me how much H plus ions you need to balance this. You are doing this from your 7th or 8th standard of the chemistry. So I hope all of you can just quickly write it down and just solve this. No need to spend much time. Okay. This is a very easy question. I'll not wait much. Just you have to balance this equation, and you can see NO3 minus was there. So this balance to balance this charge, I am just like here is plus. I'm taking one electron here in this portion, or in this side, uh, my left hand side, and this right hand side, you can see that there was HNO2 plus. So there was no hydrogen here. So you have to take care of the hydrogen. So I am adding H2O and then it is H2 and H3H. So this is 3H plus. So very easy one. You can solve like this also. Or you can go for the elaborate process for the solution of redox reaction or the balance of the redox reaction. How to know, you know how to do this. If this was very easy one, so you can just like that you can also solve this. And you need 3H plus ions, right? And then we will go for this 7 and 8. So this question number 7 and 8 are the connected questions or same data question. Please write down the data from the question. FeCl3 is often added as a flocculant to water in the treatment plants, and for the problems below that the FeCl3 added is 10 to the power minus 4 moles, and assume that the very hydrate, right, that is FeOH whole 3 is in the precipitate form or solid form. That's why S is written. Is the only solid form there. So use vMintech software, determine the pH and dissolved iron concentration in percentage term if FeCl3 were added to the pure water. Options are given. You just have to calculate using vMintech software. They will go for the solution. So the answer will be D. I'll show you how to solve this. So at the values, you know how to use vMintech software. So we are using this form for a long time. I hope all of you can give the inputs. So first input is add components, go there. From the drop down, you have to give the inputs. Two inputs you will give. The first one is for Fe and then Cl minus, Fe3 plus and Cl minus 1. And for Fe, it will be 10 to the power minus 4. For Cl minus, it will be 3 multiplied by 10 to the power minus 4, because from 1 mole of FeCl3, I am getting 3 moles of Cl minus ions. So that is the basic result. So I'll write here as it is written Cl minus 3e minus 4, 3 into 10 to the power minus 4, add and then add this Fe also. Go to this view and edit list. You will be able to see this. Fe3 plus is 10 to the power minus 4, Cl minus is 10 to the power minus 3 into 10 to the power minus 4. Then go back to the main menu. Then go to the above section. There is add infinite solid phases section. From this drop down, select FeOH whole 3, this one, FeOH whole 3, and if you just select FeOH whole 3 here, go to add, then if you run the vMintech software, you will get this. Right? So all of you are very familiar with this. So I can see what is the pH here, 3.537, and I'll go for this pass percentage, right? It was asked the form of percentage. Yes, pH and percentage. So I'll go to this table, this mass distribution table, and then I can get this percentage, right? So how much percentage is having with Fe3 plus? Uh, is it correct? 2 point. Okay, yeah. So how much we are getting? 2.051, right? So if we just round up, I think it's given in the round up format. So this 2 point, nearly 2.26%. So this is the closest one, right? Closest one with pH 3.54, round up pH, and if it 3 plus dissolve 2.26. Okay, okay. Yeah, I actually will get to this from a different, from this table. We will get this. If there is a mistake, I'll show you using the actual table later. So yeah, there is a issue like I took from the different perspective. I will get this. So the next question is connected question. Water initially had the alkalinity of 150 mg per liter as CaCO3 and pH of 8.3, right? Assume that all the alkalinity is a form of dissolved inorganic carbon that you have to assume, and what are the pH and dissolved iron concentration at equilibrium. You have to find out this. These are the options. So we'll go to the solution, or solution of the answer will be C. Everything will remain same from that previous problem. Just you have to go and specify alkalinity, right? And also you have to give the input for this pH, right? pH 8.3, right? So pH will be 8.3, and give the input for this alkalinity. Go the section above. I'll show you from the actual software. Then from the drop down, select CaCO3 mg per liter. Write down how much, 150. This is normal. Go OK, and then run the Fume check. You will get this table, right? So pH is 8.3, and if you go to the distribution of components, dissolved and other things, mass distribution, and then you will find that percentage dissolved. So what was the question here? It was asked the percentage of Fe3 dissolved, right? Fe3 dissolved. So here I can see that Fe3 is 100% in the dissolved form, right? So the correct answer is 100% with pH 8.3. The next or the last two questions are also connected questions. We all know that we use some oxidant to remove ions from the water, right? So the presence of iron in the natural waters has been known to create problems in the potable water treatment and distributary systems. To remove this iron is very essential to make the water aesthetically acceptable and to ensure the integrity of the distribution system, right? And conventionally, water treatment plants used chlorination and aeration to remove the iron and to form the precipitate of that iron, and it will be easily removed. And it is proposed to use a strong oxidizing agent like potassium permanganate. Now this is the proposed reaction. It may happen inside the water. Fe2 plus MnO4 minus, it is converting into Fe3 plus Mn2 plus, right? This reaction needs to be balanced using the method of half reactions. Again, the same thing. It's a 7th or 8th standard chemistry question. Let's try to find out how much numbers of H plus ions will be needed to balance this, right? Just a minute. Like I told you to show, I'll show this. So for the previous question, last question, I just forgot it. So that's why I'm showing right now. Let's check this. So you need to go to here, parameters and specify alkalinity. Here you can select this one, and if you can go for 150, go add, then run intake, and you will get this pH 8.3, right? And click here, you will get how much is dissolved. So this is 100% dissolved form, right? So that's what I was saying. And for the previous, like the question number 7 also, there was no mention of the alkalinity. Then don't go here. Just select here. Just go there, and from the drop down, you need to select the Fe3 plus and Cl minus. Go to the view and edit list, you will find these things. And this is coming due to the setup I have done with this alkalinity. Just forget this last line. This concentrate with these first two. That will be your scenario for the previous question. And if you just run the Humantek, then you have to go to this table. So that's what I told you in the last section, that you need to go to this table. So that's it. Now concentrate with this problem. The reaction needs to be balanced with the method of half reaction. Okay, this is very easy, so I'll not wait anymore. So the solution is something like this. I will say everyone should try this. Like there is nothing to discuss from the beginning. That's why I'm just giving the direct balanced equation of the reaction, and it is very easy to balance. That it is very easy to balance. No need to go for any electrons and all. So this is the balanced equation, and from here you can see this there is 8 uh, water H2. So 4 multiplied by 2, it is coming 8, and we need to balance 8 hydrogen ions. So I'm writing here 8 H plus. So this will balance each other. And other things is very easy to balance, because there was only Fe2 plus and Fe3 plus, just write 5 5. And here is only 4 oxygens are there, and we are getting 4 oxygens here only, right? 4 multiplied by 1, 4. So this is very easy one, nothing else. And there is another question, related question in the finally balanced equation, which I showed you, this one. How many moles of MnO4 minus O4 minus would be required to oxidize 1 mole of Fe2 plus? You have to write. So this is the equation. Suppose, so how many moles of MnO4 minus will be required to um, oxidize this one, Fe2 plus? Right. This is also a very easy question. So for 5 moles, it was needed 1 mole, right? For 1 mole, how much will be needed? 1 by 5, right? For 5 moles, if it is 1 mole, then for 1 mole, how much it will be? 1 by 5. So very easy unitary method, right? I hope you can understand. So there was 1, there was 5. So for 5 moles, I need 1 mole. For 1 mole, how much I will need? 1 by 5, and that is will be nothing but 0.2, right? So this is nothing but 0.2. So this is my correct answer, zero point 0.2. Thank you everyone for joining and watching today's session. Hope all of you have enjoyed today's session regarding these redox reactions. We will meet the next Saturday at the same time. Thank you. Thank you everyone.